Greetings from Kamaraj College of Engineering Technology. First of all, I feel very happy to introduce myself. I am GANESH, completed B.Tech-IT and M.E. Computer Science Engineering, working as an assistant professor in the Department of Information Technology in Kamaraj College of Engineering and Technology. Today, we are going to learn about the distance vector routing algorithm in computer networks. After seeing this video, we are going to get the following outcomes. First one is introduction, and second one is key steps and example problems and advantages of distance vector routing algorithm and comparisons between the distance vector routing algorithm and a link state routing algorithm and that real world applications of the distance vector routing algorithm. Before that, we have to know what is mean that routing. Routing is the process of selecting the best path for data packets to travel across the internet, which ensures the information which reaches to the destination in very accurately in very efficient manner. There are two main types of routing algorithms are used in modern digital networking technology. First one is distance vector routing algorithm, which is otherwise known as Bellman-Ford algorithm, and second one is link state routing algorithm, which is known as Digestas algorithm. What are the steps we are going to follow to implement distance vector routing algorithm? First steps, to initialize the router values. Every router has specified and interconnected with every node. Here every distance of the routers are specified with the cost value of the distance. Here each router starts with knowledge only about its directly connected with the neighbors. Then here we have to set that initial value as 0 and neighbor node as specified as infinity. Then here exchange of routing information. Second step, that step message that routing tables to neighboring routers at fixed intervals. Then we can follow that other steps, Bellman-Ford algorithm calculation, which plays a very crucial role in that algorithm. It says that if a router receives a router update from a neighbor, if it check if the new path of shorter than existing one. Suppose if I find a shortest path, I can choose that path from old path to new path. Then convergence, here after several updates, that updates are stored in a database. That database all router eventually have the best possible path to each destination. Here we are going to compare distance vector routing algorithm with the link state routing algorithm. Distance vector routing algorithm is a foundational concept of a routing algorithm which is mainly used in digital technology. In that, in topology side, we can compare each router's node the full network topology in link state routing algorithm, in distance vector routing algorithm which know only a neighbor information. Then in convergence time, which makes more faster, and in distance vector algorithm it's too low when compared to the link state algorithm. Then algorithm used here, link state algorithm, Digestas algorithms are used to solve that link state routing tables. In that method we are using Bellman-Ford algorithm. Then overhead here we are using more memory required but less bandwidth in that method. But here less memory but we need more bandwidth. Then in example protocols, open shortest path, then intermediate system to intermediate system. Here routing information protocols and enhanced internet gateway routing protocol. By using the Bellman-Ford algorithm, we are going to solve some example problems in that session. in examination point of view, they can ask this kind of questions to solve a distance vector routing algorithm. Here we are having 5 kinds of nodes. Every node as called as routers. Okay. Here A, B, C, D, E are all nodes are interconnected with the undirected graph. Every routers are connected with some cost values. The distance of the data is called as cost. Here A to B the cost value is 1, then A to C the cost value is 5. Similar like all kinds of routers are having some values of cost estimations. Then before that we are going to calculate a distance vector algorithm, we need to put 4 kinds of columns. Every verticals of the columns have some contents. First one is destination, and the second one is cost, and third one is next node, and fourth one is optimal cost calculation. First we need to travel from A to B. Then A to B my cost value is 1. So that here we are writing as 1 as a cost. Then we need to find out multiple choices to travel from A to B. Some person will travel as like in the route A to B. Suppose someone will travel as in the route of A to C, C to B. A to C, C to B. Suppose A to C it takes 5 as a cost estimation, then C to B it takes 3 as a cost estimation. So that here I am getting 5 plus 3 equal to 8. Someone will take another choice. He travels A to C, C to E, E to D and D to B. Here then every traveling time has some cost estimation. So that A to C is 5, C to E is 4, E to D is 2, then D to B is 9. Answer is 20. Okay. Here we can get 3 kinds of distance values. Someone takes 1 as a distance, someone takes 8 as a distance, and the other one takes as 20 as a distance. Here the shortest path is A to B equal to 1. So that here I am writing my best path value is 1, my next node is B. So that here I am writing as B as my next node. Similar like the same methodology will follow the next iteration. Here A to C, my next route I am going to travel from A to C. Then what are the possibilities we are having to travel from A to C? First choice, direct choice, A to C, it takes A to C is 5. Then second choice, I can travel from A to B then B to C, A to B then B to C. So that here I am getting 1 plus 3 equal to 4. Then I am taking another choice, A to B, B to D and D to E and E to C. Okay, this is here I am getting 16 as a cost value to travel from A to C. So that when compared to the other cost values, I am getting 4 is a minimal shortest path to travel A to C. So that here I am writing my cost value is 4 and my next node value is C. The same methodology will follow the another iteration. In third iteration I am going to travel from A to D. Okay, A to D, what are all the possibilities we are having? First we have to calculate that. First A to D, A to B and B to D, 1 plus 9, 1 plus 9 equal to 10. Then next A to C, C to E and E to D. 5 plus 4 plus 2 equal to 11. Then A to B, B to C and C to E and E to D. Here I am getting 10. Here we are having same kind of output values 10, 11, 10. But B is already written in that in the destination column, so that I ignore that. Here my next node is D, so that here I am writing as D, here B. Then A to E I am going to travel. The same methodology followed in that method also. I am getting my cost value is 8 and the next node value is B. And we have to know about the advantages of distance vector routing algorithm. It gives more scalability and which supports large networks, then which has fast convergence, which changes in the network topology and which supports all kinds of topology are quickly propagated, and which gives most accurate values and accurate data to provide a consistent view of network to all routers. And we are utilizing these kind of routing algorithms in modern digital networks as a routing in internet protocol networks and autonomous systems in large networks and mobile ad hoc networks and wireless sensor networks and internet of things networks and real time multiplayer online games. In conclusion, we are having multiple types of routing algorithms in modern technology, but distance vector algorithm is a foundational type which is used to give a more reliable and more accurate consistent data transformation in the digital communication networks. Thank you so much for listening. Thank you.